Okay, in this video we're going to use our TI-83 or TI-84 graphing calculators to do an exponential regression. Now, regression just means giving your calculator some points and asking it to come up with a function that fits those points. And if the problem that you're working with happens to be a problem involving exponential growth or exponential decay, then you want to do an exponential regression. So if you take a look at the problem from your notes, we're dealing with a problem that involves sound intensity. And sound intensity is a type of problem that is an exponential decay problem. That is, the sound given off, in this case by a bell, it's very loud initially, but the intensity of that sound, it drops off very quickly as time goes on. So it says in question number 1 there, what are the independent and dependent variables in the experiment? Well, the independent variable, that is the variable along the x-axis, in this case our independent variable is just time, or you might say seconds. It's time measured in seconds. And I can tell that from the problem itself. It says the sound from the bell had an intensity of 40 pounds per square inch 4 seconds after it rang. Well, time, if time is one of my variables, it's almost always going to be the independent variable. So 4 seconds after the bell rang, it had a sound intensity of 40 pounds per square inch. So that's going to be the sound intensity after 4 seconds. The dependent variable is going to be my sound intensity. So I could say PSI, pounds per square inch, or I could say sound intensity. Sound intensity. So there's my independent and dependent variables. I'll call my independent variable time. I'll call my dependent variable, I'll just say sound intensity. Question 2 says, what 2 points would be a part of the exponential curve of this data? Well, we already have 1 point. That's this point here at 440. My other point, see, it says after 7 seconds, the sound intensity is 4.7. So let's see, 4, 7. So there's my second point right here at 7 seconds. And that's 4.7. So my 2 points, you just write these as ordered pairs here. Let's see, 1 point is at 4, 40. My other point is at 7, 4.7. Now it says use your graphing calculator to find the exponential equation that represents the sound intensity of the clock tower bell. Well, now, since I have 2 points, all I need to do is enter those points into my graphing calculator. So I hit the stat button and I hit enter to bring up my lists, and I just enter those values into my list 1 and list 2. Remember, list 1 should have all of the x values and list 2 should have the y values. So I enter those in, and then I hit the stat button again, go to the calc menu, and if you scroll down to the one that has a 0 next to it, that says exponential regression. And so I select exponential regression, I hit enter, and that comes up on my screen. It says exponential regression, and then if I hit enter again, then it will calculate the function that fits these 2 data points, that is the exponential function. So in this case, my exponential function is y equals 695 times, I'll call this 0.4898 to the power of x. Sketch a graph. I've got my graph sketched right here. Number 5, notice, says what was the initial intensity of the sound? Well, even though I'm not given that information in the problem, the initial intensity of the sound is just going to be the initial value from my exponential equation. So my initial intensity of sound is 695, and that's going to be pounds per square inch.